So everybody knows Dennis Gannon, and there's no particular need to introduce him. So rather than introducing him, I want to uh, just comment on how nice it is to have him back in the state of Indiana. He has had a tremendous influence on the entire community, on Indiana University. I remember the year that Dennis Gannon and Randy Bramley were both out on sabbatical at the same time. I made a decision. It was clear that either both would come back or neither would come back. I decided that if neither came back, I would leave as well. Dennis came back, and it is a sign of his influence on Indiana University that while he left a gaping hole when he went to Microsoft last summer, it was a hole in something, and that's a sign of the extent to which he has influenced the development of computer science and informatics at Indiana University. And hopefully we will hear from Dennis about the things that he is continuing to do to influence the community through his work at Microsoft. So Dennis, thank you.
That my legacy is leaving holes, and I always try to dig one wherever I go. I also told Craig that we should encourage the discussion after on the breakout reports to go as long as possible, because I told him I had very little to say, and so we could do it very quickly. And I have very little, I think, to add to this community. I'm no more knowledgeable about this subject, nor do I have any fancy magic bullets to deliver than anybody else in this room. So I'm Dennis Gannon. My current job is with an organization called the Cloud Computing Futures Center, part of Microsoft Research. What we do in the Cloud Computing Futures activity is to try to think about the applications, the software, the architecture of where the company's cloud systems will be in 7 or 8 years. So it's a fun project, and we're also now engaged in something that to me is very exciting, which is to try to take some of our direction for what we do with the future of cloud computing from the scientific research community. And so we've been going around, and we're going to continue to go around more and more, talking to the community, saying, what is it that you need? What can we provide as a company that would make it easier to use this different type of technology, different from traditional supercomputing, for scientific research? Now see, I only have a few slides, so I did have to spend at least 3 minutes on the cover slide, so I've done that now. All right. And again, most of what I have to say is stuff that has really been said in much greater depth and eloquence in these wrap-ups of the breakout sessions. But the bottom line we all know is that to make software systems sustainable, it's really about a business model. And that's how any software gets sustained, and it's true for the type of cyber infrastructure that we do, as well as something like Microsoft Word. And so, but business model in this case can be a lot of possibilities. What works? Well, so if somebody's willing to buy it and pay for it, that's really great. That's golden. And in particular, we see examples of that. We talked about NanoHub a little while ago, where they have a very nice business model. If I could, Gerhard doesn't mind me sort of paraphrasing our discussion earlier, which is sort of a combination of institutions that absolutely are willing to commit real dollars. And by institutions, I mean not government institutions. Institutions willing to commit real dollars to the sustaination of NanoHub, or in particular, large communities that are willing to sort of, I think the expression was, hold a knife to the back of the neck of the funding agencies to make sure that the software continues to be sustained. That's sort of the blackmail model. And the combination of direct cash from happy users and constant pressure on the funding agencies to support something is a very good business model. Another one is government requirements. A lot of software gets sustained in the scientific world simply because the government must have it maintained. I think, so maybe I was thinking maybe the CA grid stuff, or CA big in particular, is an example of that. I think we may see something coming up in the future in terms of software from the current administration's push on medical records. I think that's going to result in some very sustainable software models for the industry in any case. But there's other examples of more purely scientific of government requirements. Within the DOE labs, most of the large codes are there because the government insists that the weapons program, that we maintain the stability of the stockpile. And that's pretty much going to sustain those guys for a long time, or at least until it's no longer, until the stockpile decays or something. All right, so the other possibility is industrial or foundation patron. There are pieces of software out there where there are foundations that need the existence of that particular piece of software to be continued. I think what will happen there is, for example, in the case of some of the software that Brad talked about, it is really critical to various foundations. They're willing to continue to support it. And by foundations that are industrial or institutional, I should say, is a possibility that is extremely important. Now, the final one, I think that's another method that this is probably the least popular. In particular, if this is your mode of operation, is a sort of a continuous stream of short-term grants from agencies to sort of keep it going one more year. So every year you are reapplying for another grant from some other program. Oh, well, there's a new program solicitation out. I think I can take this piece of software, paint some stripes on it, and tell them I can sustain it. I can build on that software to fit into this piece and therefore sustain it for another year. And a lot of people try to use that model. That's rough life. Now, what doesn't work? And so rather than sort of point at examples, what I'm going to do here in this next slide is point at mistakes I have made. And this is oh, by the way, I'm not speaking, I forgot to say this at the beginning. All right, I should go back to the beginning slide. I won't. I'm not speaking for the company of Microsoft. I did not vet my slides with the large number of lawyers we have or anything like that. This is me talking. And so in particular now, this is me talking about my life as an academic and a builder of software. So things that I have tried, all right, that is building scientific research tools that have a very specialized and small set of users. Now, some people can do this. They can build something for a small set of users that turns out to be fabulously good, and that set of users grows and grows and grows over time. Or in particular, I'd say the best example is there's someone who builds a piece of software to please themselves, and they happen to have such good taste that piece of software really becomes a standard. I think Linux really started that way in many respects. I think you could take a look at, for example, Stephen Wolfram, wanted to build software to do symbolic algebra the way he thought it should be done. He was also tired of writing grant proposals, and so he created a little company called Mathematica to do that, and that's worked out pretty well for him. But in general, if you just have a small set of users, that's not going to be enough to force agencies to continue to fund it. And the only solution you may have is to fall back onto the continuous stream of small grants to fund your work. Another mistake I've made is to work on a project that's a lot of fun, but you're really competing with a bunch of other very similar projects for the same NSF DOE support dollars in a community of people that are doing the same thing which refuse to collaborate. And the best example I could give of this is the community that I've been involved with scientific workflow. There's something like last time I counted was about 8-10 months ago, and we had 24 different scientific workflow systems out there, each of which did pretty much the same thing, but each had one cute feature that particularly was the brainchild of its creator, and they were all competing for the same funds. They still are. They were all refusing to cooperate with each other, or in some cases 2 or 3 at a time would collaborate, but but getting them to sort of sit down and say, all right, we've tried all our experiments. Now let's, as a group, let's adopt one for the community. Let's build it for the community instead of building it for ourselves. And NSF is basically saying, Jenny, I shouldn't speak for you. Maybe you want to fund all of these. Perhaps you should. I know these people. They're good people. But my suspicion is that you're not going to fund them all. So that's really a big problem in a lot of the work in cyber infrastructure, is lots of little teams doing very similar things but refusing to get together on one solution. So I've made that mistake. Another one is assuming that open source is the salvation. Now you might think, oh boy, here he comes. This is from Microsoft now. Is he going to bash open source? No, I actually think open source is great. Microsoft is even supporting open source more and more. They're generating open source. I'm not allowed to use it inside the company because we'll get sued, but still, open source is a good thing, but it isn't, you can't just sort of throw it to Apache and start up a little group. I mean, if you look through the various different projects and Apache and some of the other open source sites, they're filled with corpses out there. I mean, these little projects that are all well-intentioned, that might have started by one or two people, and then fail. A lot of the open source projects that seem to go on that have continuation are largely have some sort of financial backing, or for example, it's important to some group of companies and they're willing to actually pay some of their developers to continue to support and to work on that particular open source project. And that's great when that works, and that's terrific, but just making it say, well, my solution is open source, that'll sustain it. No, that won't work. And another related to that is to say, well, I'll create an open source, but I will also create a little company. I'll have a startup which will provide the financial support to maintain a professionalized copy of this thing. Well, it's like any other startup. The likelihood of success of startups, no matter how well intentioned, the likelihood of success is very low. It's a tough business being a startup. Finally, here's a real killer. I've done this a couple of times myself. Is to say, all right, I've got a brilliant idea. There's a community code out here or a piece of technology that is very popular. I've got a brilliant idea of how to make it much better, so I'm going to branch that open source code, and I'm going to make some massive changes, extend the semantics in interesting and clever ways, and then lay that back on the community. Boy, can that be a bad idea. The acceptance, the community acceptance for some lame academic's piece of modified version of your standard community source is, well, let's say it makes you feel like something wrong with you when you get the reaction from the community for doing that. And there's been many, I would call them dead programming language compilers for parallel languages based on extensions of this or that well-accepted programming languages, simply because the community wasn't going to accept it because they could not see how it would be sustained. So those are things that don't work. All right. Now, I want us to talk about another approach, just a little bit. And this does not at all cover, I would say, any substantial fraction of the potential challenges we have for software sustainability. It is essentially one thing that I think can work in a lot of cases, or in a bunch of cases. All right, and that is to really take a successful commercial or strongly supported framework and to just simply add on really great pieces to this. And this is something, for example, there's really quite a good sustainability story for Eclipse, which has, as we know, serious commercial entities on the East Coast who are very keen on making sure that Eclipse remains a viable programming environment, and it is pretty darn good. And by creating different plugins for Eclipse or different extensions, you can actually have a community that builds upon that. Portals, for example, for many of us have worked in the portal community for science applications, have relied on things like GridSphere, which was done by some great young friends of ours who are now all in business or being quants on Wall Street or whatever. They're no longer working on it. But IBM is still supporting WebSphere, and maybe That's a well-established, it's a commercial framework. And by building on that for science portals is maybe a better idea than adopting one of the standard open source tools. Within Microsoft, we have something in the case of science workflows, something called the Trident workflow system, which we're going to release for anybody in the scientific community to use. And that is built on the underlying Windows workflow foundation, which is, it's a core part of the Windows operating system now, and it's pretty good. And this is something that could be used as a foundation for a lot of the science workflow applications. It runs on Windows, but it can manage services running on Linux or other platforms. It's not only restricted to Windows type applications. Now, something else, and this has got a one-liner here, but it's actually something that I care very much about, and it's come up before, and that is working with industry must be a two-way street. So what do I, question? Oh yeah. That's right. Yeah, you're not guaranteed that something is going to. Well, I think that the question is longevity. How long will something last? An open source project could die with the next funding cycle, right? And they run out of funds, everybody's gone. Something like Windows Workflow, I think, will be around for at least 3 or 4 or 5 years. Okay? But you're right, you can't rely. Software does evolve rather quickly. You know, I don't know if I could, in terms of planned obsolescence, I don't see that happening around me at Microsoft. It's not, all right, this is planned to be obsolete. No, what you do see is that anytime there's a commercial product out, there's always a constant development for a better version coming along later. So it's not an issue of, well, we're going to kill this off and make everybody buy a new one. Well, I see a great deal of effort within our product groups on backward compatibility. It's a huge issue because the customers get absolutely furious if you completely leave them stranded. So that's an enormously important point in terms of what the company has to do is to support backward compatibility. If they're going to come out with a completely new version of something, they better have the tools in place to convert the technology that you had before to work with a new one, or working with, for example, the vendors that other vendors that rely on your technology. There's enormous amounts of effort spent to bring the next, new generation of technology, to bring them up to the point that they're compatible with it even before a release happens. I'm getting into things that come close to talking about Microsoft policy, which I certainly can't do. Yeah. Yeah. Gerhard. So yeah, maybe I don't know. I've heard like TerraGrid, the TerraGrid gateway is going with WebSphere. I think they seem to have had good luck with it. I'm not, trust me, I'm definitely not here to endorse an IBM product per se, but now, I mean, your comments are well taken. I think though that that this is an avenue, and actually, I think so. I think people that work with you are able to use this principle very well. And the Nano Hub is a strongly supported framework. I said successful commercial or strongly supported framework. For example, and people are able to come to Nano Hub, get something up very quickly, and do basically add on for their science technology into Nano Hub. So that's an example of what I'm talking about as well. All right, now let me get to this other point, which is, I think, to me is very important, is this industry engagement issue. As industry tries, as a commercial sector tries to engage with the scientific community, I think somebody mentioned that, you take something and you hand it over to some company to develop and harden, and then all of a sudden the connection is lost to the scientific community. The industry people don't understand the underlying science. Yeah, that's a serious problem. And I think that one of the things that we're trying to do in our group is to engage the scientific community in real partnerships as we move into some of our cloud technologies, is to understand that we know that we're not the experts on some of the science. And so when we look at possible systems that might use the Microsoft Cloud architecture in scientific applications, we're not going to be able to do that in the back room and come out with it as a product. It has to be something that is a community effort in collaboration with the scientific community. And coming from that world, and as well as half of our group comes from that world, we understand that completely. But that's so easy to make this mistake of not making it a really deeply rooted collaboration. Now, services. So this is another thing. This relates to, this came up in a couple of slides, software as service and as a way to reach larger communities. And we've talked about examples of science gateway portals or online data archives. And I really believe that this can be hosted on commercial platforms in a way that is truly liberating and more scalable and more reliable than what we have seen for the most part in the academic sector. And I'll come back to that in a minute, actually. But another phenomenon that's happened is we take a look at the success of some things that have come out of industry. The Hadoop project, which comes from Yahoo, which is based on ideas that originated in Google for doing large-scale data analysis, has been actually embraced by NSF and provided as a resource. There's something, Microsoft has a very similar thing that we're about to open source, which is Dryad. And Dryad integrates with, those of you that are familiar with the Link technology and the programming language support that Microsoft has capabilities very similar to Hadoop and in some ways better. And these are a data analysis framework. So this is frameworks that come from the industrial sector, providing a new set of capabilities to the scientific community that we want to encourage. There's a competition among companies like Google and Yahoo and Microsoft and IBM to help. There's a competition to gain mind share among the scientific communities around these tools, because the ideas that come back for how to improve them are rather significant. Now, and that relates to actually this is really related to my first point on this slide, is about some of this technology that's out there in the commercial sector that is now really providing new capabilities that we did not see before. And the things that, in particular in terms of reliability and scalability, that as I worked with TeraGrid for many years, I know were not there. EC2, the Elastic Compute Cloud from Amazon, is well as their storage service and a host of other services built on top of it. Google has their app engine, which is a way to, an elegant way to use Python and deploy it in the cloud and gain access to a number of their Google internal data structure engines. Microsoft has something called Azure now. You have to use the French pronunciation or the Redmond, Washington pronunciation. It's Azure. Azure is how we say it in Washington, not Azure. And these are all frameworks for building scalable applications and deploying them on the hosted infrastructure provided by these companies. And the cost is relatively low. All of these things rely on some form of virtualization and VM technology running on rather scalable platforms. And we feel that there's a great opportunity for a large class of scientific, largely data analysis applications, not the big MPI codes that run on our supercomputers. They're not replacements for that, but they provide a different way to do a lot of large, important scientific calculations. Oh, I wanted to come back to something related to that. Is MATLAB. This is another thing that is very, very interesting, and being able to run large MATLAB computations in the cloud is something that I think everybody is interested in. MATLAB is really great, especially if you like a strongly typed language where there's only one type where everything's a matrix, but it's really great. Okay? And it is an amazingly powerful tool for scientists. Its only drawback is the licensing requirements are a killer, but it's really good. And pardon? Oh, believe me, Microsoft, it costs us to use MATLAB a lot more than it costs you guys. Ooh, it's expensive. And so we're trying to figure out models in which we could take tools like MATLAB and make them available as part of cloud services. All right, so what does Microsoft currently do, and what should we do? And this is where I sort of wanted to leave it with some comments and suggestions from the community. In terms of the open source round, I described sort of where we're going, a little bit where we're going with this engagement with the scientific community. You'll be hearing more about that later. Microsoft is one of the supporters of Apache, at least so I've been told. I don't know the amount. We have a new open source program. We've open sourced a bunch of things, plus we're now hosting open source applications that are in the web area for web type applications. And that looks pretty interesting. And then the three question marks is really sort of turn it over to you. And I would be very interested to get your feedback on what do you think Microsoft should be doing to help this software sustainability issue some more. So, and I'm done. Stephen, this guy would know since he knows the company, being a former Microsoft employee.
Yes, so I must disclose that I was a Microsoft employee up until 5 months ago, which doesn't matter. So I can speak.
And we hated to lose him, by the way.
I can speak without any fear of prejudice from Microsoft. So you've spoken at Microsoft. Microsoft is a big organization, as we all know. How much from what you say is related to what MS Research might do, and how much MS, the product organization, might do in relation to, say, open source engagement in open APIs to allow plugins for science community to build upon and so forth? Is there a divergence between the two organizations?
Well, first of all, again, as you know, I cannot speak for the company here, but I can say that this whole, what I have seen, I'll say that, what I have seen is commitment, and this is since you've been working with the company. In fact, they were so brokenhearted when you left that this changed their whole thinking about everything, and it's gone all the way up to the top at this point, and they're quite interested in this. We lost Steve Newhouse. What have we done wrong? So.
It's nice to know the best way of affecting organizations.
So any other suggestions for the Empire? Yes. Uh, yes. So that's a good question. Actually, since I'm in Microsoft Research, we don't test anything. But no, seriously. No, actually, Microsoft Research is very much like a bunch of academics. They do what they can. Yeah, it's tested. We ran it twice. It worked. Uh, you know, um, we do a lot of demoware. And as a matter of fact, so the role of Microsoft Research is not to produce product, is to produce ideas that, we literally go around and try to shop these ideas around to the actual product groups who say, that's interesting. Maybe we should start an incubation effort, and then that incubation effort becomes a product effort, and then the product effort builds up generally a testing team. Actually, Steve might answer this question a little bit more because he was in one of the product groups, and so he knows about the testing probably better than I do. No, anyway, yeah, suffice it to say that there's a lot of testing that goes on in terms of how much best practices they have that are, um, as far as the best practices they have that are well beyond industry standards, I can't even comment on that. Thank you, Steve. Glad I didn't say that. Other suggestions? Yes. Pardon? Um, any chance Dryad will run on Linux? Right now, Dryad runs on the HPC server platform. Are you interested in doing a port? We'll talk about that. Um, yeah, I don't know if they have any plans to do that. My guess is no. That's a very good point, actually, and it occasionally comes up in conversation, I should say. Okay. Suresh. We're back on WebSphere now? Right. So, yeah, Gerhard, will you be willing to, as you indicated before, that if you had depended upon a piece of software, would you be willing to fund the development of that?
We took a piece of software that didn't quite do what we wanted, and WebSphere didn't at all do what we wanted. And we spent time and effort to augment into Joomla and into Mambo the components that didn't exist. And then we put those back into the community.
And
So yes, we took
so,
something somebody else developed and built on it,
right.
but we had 80% or maybe 90%.
So it worked very well as long as the keepers of that group do integrate those improvements in there. Otherwise, you get an orphan branch. But yeah. I think now Craig kept talking about something involving beverages. I think is that time for.